In this chapter, we get back to graphing linear inequalities. We will get back to matrices, but that will be in the very next chapter where we put inequalities and matrices together. So first thing, with linear inequalities in two variables, the inequality symbols, what they mean, and normal words used in a word problem, because we do get some word problems. Here's a less than, and if you'll notice, less than's used in a word problem. Greater than, sometimes they use more than. Less than or equal to, they like the words at most. Greater than or equal to, they like the words at least. And a lot of people, when they first look at this, they think of less than, but at least is a minimum value or more. So you've got to be careful when you run across the at most and the at least words. Now, any value that makes an inequality a true statement is a solution to the inequality. We're going to find out that we're going to have sections on a graph. A half plane is actually what it's called. But let's go a little bit further. We'll see. Graphing linear inequalities in two variables, an inequality will have as its solution set a half plane. A half plane is a set of all points on one side of a boundary line. So here's some terminology that we need to look a little bit more into, and you'll understand where these words are coming from. So to graph a linear inequality, first change the inequality symbol to an equal sign, then graph points as if it were an equation, but do not connect the points at this time. Step 2. If the inequality is a less than or a greater than, we use a dashed line to connect the points found in the first step. If the inequality is a less than or equal to or greater than or equal to, we use a solid line to connect the points found in the first step. Why we use a dashed line is that indicates that the points on the boundary line don't work, whereas a solid line indicates that it does. Step 3, almost done. Pick a test point away from the boundary line. Put the test point into the original inequality, and if the statement is true, then shade that side from which the test point was picked. Or if the statement's false, then shade the opposite side from which the test point was picked. Because guys, if I do a line, then I've got my graph cut in half. One side works, one side doesn't. So let's see some examples. We're going to graph the following inequalities. So first thing I've got to do is change this to an equal sign, and then I get myself some points. Now I know some of y'all like to graph the equations in y equals form, but you really need to get used to what's called the intercept method, because most of your problems are given that way. The word problems end up that way, and it does save time. So intercept method, I make a t-table. I let x be 0, I let y be 0. If I let x be 0, think about in this problem, if I let x be 0, then this piece right here will cancel out. I end up with 2y equals 10, or y will equal 5. Now I have to turn right around and let y be 0. Well, if y is 0, this term drops out, and I divide both sides by -5, I end up with x equals -2. I'm going to graph those points. Okay, so right here, first change the inequality symbol to an equal sign and graph the points as if it were an equation. So that's all I did. I graphed my points. It would be nice if you do label. Right now it just saves me time, and this thing's not that huge. So I did graph -2, 0, and 0, 5. Now, in order to connect them, the inequality symbol has an or equal, so I need to use a solid line. So use a solid line to connect. Now I've got to get a test point. I can get a value over here, or I can get a value over here. I usually use the origin. That's the coordinate point 0, 0, as long as my boundary line doesn't go through it. So let's go back up and see what happens. If I put 0, 0 in for my y and my x, I end up with 0 is greater than or equal to 10. You have to make a decision. Is 0 greater than or equal to 10? Hopefully you said false. So if the statement is false, then I shade the opposite side. So I chose my test point here, so that means I'm going to shade this side over here. And you just shade. I think I used a color. Nah, is that not cool? So all these points that are in this section work in my inequality. Now if you'll notice, I did label the equation I used to find this. You'll find out why a little bit later. So you just need to go ahead and get that in that habit. So I've got another one. So I need you to try this one. Let's see what you end up with. First thing, make it an equation. Second thing, get you some points. So go pause me, go get some points, and then see if you end up with what I do. Now go graph them. But do not connect. Don't ask. I don't know why it jumped. Okay? So now you have to make a decision. How are you going to connect those points? Look back here. If it does not have an or equal, remember, use a dashed line. Okay? Now, try the origin as a check. If you put the origin in, do you end up with a true statement or a false statement? Putting in the origin, I end up with 0 is less than 6, true statement. So I'm going to shade the origin side. And also label the equation you use to find those points. So that would be my solution right there. So you've got some problems to do, and we're going to use every bit of this in the next section. Thank you.